thank you for watching the Introtech video presentation regarding the blood component detector. Here, I'll give you a brief presentation, discuss some of the various common configurations, as well as give you a live demonstration of the Introtech blood component detector. The blood component detector is a device that's designed to detect blood component in clear medical tubing, such as this. There is a whole host of applications that need, if not require, the detection of trace amounts of blood in clear medical tubing for various types of media. One particular application that comes to mind is hemodialysis, where in the event of a membrane rupture, there would be consequent blood leak into the dialysate, whereas the blood component detector will be able to detect and report that accordingly. The main benefit of this technology is that it is non-invasive, where we do not need to come in contact with the media to detect the presence of blood. Here we utilize the optical principles of transmittance and Beer-Ambert's law to do the primary blood detection. We transmit ultraviolet light transverse to the tube, where Beer-Ambert's law permits the absorption of this ultraviolet light by the red blood cells. There are several key configurations. One, which is standalone electronics. Two, which is RS-232 terminal mode, and the third one, which would be an integrated design, which I will show you now. This is the standard electrical interface connection, where you can see we have the main PC board here, and we have the sensor head plugged in here. The main board is powered by 5 volts, through the electrical interface cable, and you can see there are several other electrical connections that are made here. You have a self-test and a zero, which I will discuss with you in a short while. Here is the blood component detection output. The output is normally low for no blood and toggles high for the presence of blood. This is the configuration for terminal mode, very similar to the standard electrical interface. However, there is a third connection that is made here for an RS-232 cable. Here again you have the sensor head plugged into J3, you have your power supply connection, and several other connections made as well. The third and final configuration is the design integration mode, where we would provide you all the information necessary to be able to populate your main board with the electronics that drive and operate the blood component detector. This is the most elegant of all the configurations, would represent the most economical and the most space-saving configuration as well. This is the sensor head, and this is the interface board for the sensor head. We'll go into the lab and I'll give you a brief demonstration of how this works. Here we are in the lab, and I'm going to demonstrate the blood component detector in the terminal mode. Terminal mode is very advantageous for those doing test and evaluation, because you could read in real time what the blood component detector is seeing. Additionally, you can program the thresholds and the set points of the blood component detector using a standard desktop PC. Here we have the blood component detector, the sensor head, and the main board. The main board is powered by a 5 volt DC power supply with the electrical connections that are described in the reference sheet. The RS-232 connection is here on the board and plugs directly into the DB9 connector in the back of the desktop PC. I am going to load Hyperterminal, which is the main communication program for communicating with the blood component detector. Load Hyperterminal. There's a connection description screen that comes up. I'm going to write test 1. OK. The next screen, it asks for a connection port for the RS-232 connection. In this particular case, it's COM3. I hit OK. The next screen is communication properties. Set the bits per second to 57,600. Leave the data bit at 8. Leave parity at none. Set the stop bit, leave at 1. And the flow control change to none. Okay? Hit apply and OK. The next thing you need to do is invoke communication. Hit Control U to initiate communication with the blood component detector. Okay, after hitting Control U, you can see we are now live with the blood component detector, reading in several parameters. The first part of the screen here, it says blood detection set point. And this is the numeric value that represents the set point that is currently set at. The second field here is the blood detection level, and this is the actual level that's being read in real time that the blood detector is seeing. Secondly, we have a 0 and a blood alert. It's very important that the sensor is zeroed to normalize each unique tube insertion. To do that, you need to inject clear liquid or saline into the medical tubing and then hit the letter Z. Okay? If the sensor is zeroed, it would denote that by saying zeroed, yes. Okay? Secondly, this next field here says blood alert, no. So there is not enough blood concentration in the medical tubing to generate an alert. Now we could specifically change the set point here to whichever threshold we like for this particular test. And you do that by depressing the letter S, the numeric value for the new threshold, and enter. In this particular case, we'll set the new set point to 150. So we'll hit S150 and enter. You can see the blood detection set point has now changed to 150. Therefore, when the blood detection level here that is read in from the sensor equals or exceeds the number 150, the blood alert will respond accordingly. So what I will do now, I will come down here, I will toggle my valve, and I will inject some blood into the stream. Going back to the screen here, we can see that the blood detection level being read in by the sensor now exceeds the set point, therefore we have a blood alert. So as you can see, this is a very, very useful way to evaluate the blood component detector because you can vary the parameters and read in parameters as well. If this was a standard electrical interface and we did not have the computer set up for terminal mode, we would be looking directly at the output, electrical output on the main board, and be reading in either 0 for clear liquid or possibly 5 volts for trace elements of blood that exceed this preset threshold. That basically concludes the live demonstration. My name is Joseph Mariano, speaking to you on behalf of Introtech. Thank you for watching.